Hello everyone, welcome back to my YouTube channel. This is Lata and I'm currently pursuing my 4th semester BE in Sri Venkateshwara College of Engineering in the Department of CAC Data Science. Today's subject is microcontroller. In microcontroller, let us see comparison instruction. Firstly, introduction to comparison instruction. Comparison instructions are fundamental to microcontroller programming. They allow developers to make decision and control program flow based on the relationship between different values. There are so many types of comparison operators are there in microcontroller, but these are the some types of comparison which we use commonly. Firstly, equality comparison, relational comparison, logical comparison. Let us see one by one. First, equality operator. Microcontroller use equal to and not equal to. These are the symbol of equal to and not equal to, and it is used to compare values and determine if they are the same or different. Next, relational operators. It compares operators like greater, lesser, greater than or equal to, and lesser than or equal to, and it allow us to check if one value is greater, lesser than or equal to another. Lastly, logical operators. Boolean logic with AND operator or operator and not operator enables complex conditional statements to control program flow based on multiple conditions. Firstly, let us see equality comparison. In equality comparison, there are two types, that is equality and inequality. Let us see what is equality. The equality operator, that is equal to, compares two values to see if they are the same. If the value are equal, it returns true, otherwise it returns false. Next is inequality, that is not equal to. The inequality operator compares two values to see if they are the different. If the value are not equal, it returns true, otherwise it returns false. The second one is relational comparison. In relational comparison, there are four types are there. That is greater than, lesser than, greater than or equal to, lesser than or equal to. Let us see one by one. First, greater than. The greater than operator compares two value and returns true if the left operand is larger than the right operand. The second one is less than. The less than operator compares two values and returns true if the left operand is smaller than the right operand. The third one is greater than or equal to. The greater than or equal to operator also compares two values and returns true if the left operand is larger than or equal to the right operand. The last one is less than or equal to. The less than or equal to also compare two values and returns true if the left operand is smaller than or equal to right operand. Lastly, logical comparison. It contains it contains so many logical comparison, but these are the three operators which we use commonly. That is AND operator, OR operator and NOT operator. Let us see first what is AND operator. The AND operator evaluates two conditions and returns true only if the both are true. It useful for combining multiple criteria in a single decision. It will take two inputs and produce only one output. The output is high when both are the inputs are high. The next one is OR operator. The OR operator evaluates two conditions and return true if at least one is true. It allows microcontroller to consider multiple possibilities in a single check. As I said you in this, it will take two inputs and produce only one output. That output is high when if any one of the input is high. The lastly one is NOT operator. The NOT operator reverses the logic state of a condition, returning true if the original condition is false. It's handy for testing the opposite of the given state, and it is take only one input and produce only one output. The next topic is conditional branching with comparison. There are several types of branching conditionals are there. These are the some conditional branching which we commonly used. The first one is if else statements. Comparison operators like equal to, not equal to, less, greater, less than are used to create conditional branches in code, and it is allowing different actions to be taken based on the result of the comparison. The second one is switch statements. For multiple comparison cases, a switch statement can be more concise than nesting if else blocks. The switch evaluates an expression and executes the corresponding case. Lastly, ternary operator. The ternary operator provides a compact way to write simple if else statements in a single line of a code and making the logic more readable. Next, optimizing comparison efficiency. Comparison operations are fundamental to microcontroller programming, but they can impact performance if not optimized properly. By understanding comparison operator types and their relative efficiency, developers can write faster and more streamlined code. The above chart shows the relative execution time of common comparison operators. Equality and inequality checks are the fastest, while relational comparison takes slightly longer. Developers should prioritize using the most efficient operators where possible to optimize performance. Next is comparison in decision-making algorithm. Comparison operations play a crucial role in decision-making algorithms, enabling microcontroller to evaluate conditions and make informed choices. By leveraging comparison operators, developers can create complex decision trees, conditional branching, and logical decision-making processes to drive the behavior of their embedded system. Comparison-based algorithms are essential for tasks like sensor data analysis, state machine control, and event-driven response. Carefully crafting these comparison-based decision points is key to ensuring the reliability and adaptability of microcontroller-powered applications. The next topic is comparison pitfalls and troubleshooting. First one is floating point imprecision. Beware of comparing floating point numbers due to rounding errors. Use a small tolerance range for equality checks to avoid unexpected results. Next, signed versus unsigned. Be careful when comparing signed and unsigned integers, as the comparison may produce counterintuitive results. Explicitly cast values to the same type. Overflow errors. Watch out for integer overflow when comparing large values. Use data types with a large range or perform checks for overflow. Null or empty checks. It ensures us to properly handle null, empty, or undefined values when performing comparisons to avoid runtime errors. Lastly, let us see conclusion and best practices. In conclusion, mastering comparison instructions is a fundamental skill for effective microcontroller programming. By understanding the various comparison operators, applying them judiciously, and employing best practices, developers can create robust, efficient, and reliable embedded system. And thank you for watching.